sphere, perfect sphere inside your cylinder, and you've taped it shut, and you've got the height matching your sphere. What I need you to do is make sure you've taped it good and firm. What I need you to do is take and mash your sphere down into the cylinder. Okay? Now you want to mash it so that it fills the, you don't want any air in the bottom of your cylinder there, nor you don't want to mash it so hard that you squeeze the bottom of your cylinder so that it bulges out. You might put a couple of pieces of tape, one near the bottom, one near the top. Mash down and the top of your cylinder is really nice and flat, and the bottom is nice and flat, and you don't have any air pockets around. Okay, that's a good idea. Here's what I need you to do. It will now look something like this. I need you to measure this distance, how high the clay goes up now that it's a cylinder, and I need you to measure this distance, how high the cylinder, the plastic cylinder is. Okay? Closest to.
What fraction is it closest to?
These two don't work because I said, these three don't work because I said you had to have a fraction of a single digit in the numerator and denominator. So could we move those to something close to that that might give us a, what would you go to? What?
The closest thing that I could think of is, it's 2/3, I mean. Yeah.
This is close to 2/3?
Just a little. 2/3 or 3/4.
Okay. 2/3 is what? 0.6 with a bar over it, right? So 0.66666. And 3/4 is 0.75. Which one's closest?
2/3. 0.6 is
0.7 is closest to which of these numbers? How far away is it from this? 500,
You
right?
have,
How far is it away from this? This is
give
actually
a
6.6.
500 instead of a tenth.
So it would be what? 3 point something, right? It's closer to this one. So let's put 2/3 here. This one looks like it might be closer to that, right? And what?
2/3 for the top one.
2/3 for the top one.
We changed it to 0.6
2/3.
now. Since
2/3, 3/4, 4/5, 2/3, 3/4, 2/3, and this is a decimal, and what would that be as closest to? 2/3. So what's the true answer? Who measured correctly? Who rolled their thing properly? If you've done it properly and measured properly, I mean there's rolling, there's measuring, there's matching, there's all kinds of places errors could come in. It should be right close to this. In fact, it should be exactly that. Now, what does this mean? What it means is if I have a sphere, I want to find its volume. We know that the sphere, let's say this sphere has radius r. You with me? Well, what does that say about the cylinder that it's inscribed in? What would the radius of that be? Same r, right? Isn't that distance the same? Okay. What would the height of the cylinder be? Why? Because anywhere on a sphere out to the outside is r, right? So there's an r and there's an r, so the whole distance is what? 2r, right? Everybody with me? How we're getting this? So let's find the volume of the cylinder, the plastic cylinder, now that we have this. What's our formula? It's just this one without the 1/3, right? So it's what? Pi r squared, and what's our h? 2r, right? 2r. This is the volume of the entire plastic sphere. Ready to see how we got it? I took base area, pi r squared, times the height, 2r's. Okay. Does the clay fill the entire cylinder? How much of the cylinder did it fill? 2/3. So I should be able to take this amount, pi r squared, let's change, let's do it up here. Take this amount and take it times 2/3, right? So if this is the formula for the plastic cylinder and we filled 2/3 of it, then the volume of the sphere should be this. Can we simplify that at all?
4 pi r squared.
4. What happened to the 3?
Well, that'll be on the bottom.
4/3 pi, what's r squared times r to the first? Your algebra teacher taught you that you do what with the exponents when you're multiplying numbers with the same base? Add them, so it'd be r cubed. There it is. 4/3 pi r cubed. Why? Because a sphere is just 2/3 of the cylinder that it's inscribed in. Does that make sense? So, there's no need to memorize this if what? If you know the father formula, which we said was V is equal to capital BH, right? Do capital BH for a cylinder. That's what we did right here. And then we just took 2/3 of it and simplified it. Okay? The next activity, we have 9 minutes to do it. I need you, raise your hand if you brought an orange. Raise your orange. Let's just see the oranges. Raise them high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay. And we said there would be how many pairs? 14. So
We're short.
we're not even half of us brought oranges then. Okay. Some brought, is that grapefruit?
Grapefruit.
Grapefruit. It'll work. It will work. Okay, so here's what you need to do. You need to take your and get a. If you didn't bring fruit, get with somebody who's got one. And the idea was that you get with somebody who had an orange of the same diameter, the same size, or a grapefruit of the same size, and you need to cut them exactly in half. Does everybody know what the great circle means? So that when you take the thing you've cut and you stamp it, it makes the very biggest circle possible. You know what I'm saying? So here's what I need you to do. Cut your orange exactly in half. Take a piece of paper. Hold your orange half on it and trace it. Okay? Trace as many of those as you can get on a piece of paper. Those of you who have grapefruits, you might need to use 2 sheets of paper. I don't know, because you're pretty big. Trace as many as you can on there. So you're going to have to cut it, and then trace it. Make sure you cut it right through the middle. take, and you're going to have to peel the orange. Yeah, that way, that way. Peel the orange or the grapefruit and take the pieces off and place them in the circles. Okay? Place them in the circles. We need to get lined up. We need to do this fast. We got 6 minutes to do this. So if she's cut now. She can start doing her thing cut and just keep moving here quickly. What is the area of this circle right here, this great circle? The area of it. What would the area of this circle right here be that you drew on your paper? If this is R. Pi R squared, right? The area of the circle. So that's the area of each one of these circles you drew on your paper, right? Then we peeled off the surface area and it fit into how many? 4. So guess what? The surface area of a sphere is simply a circle times 4 circles. Is everybody with me? Okay. Raise your hand if you've had calculus. Ooh, even some of our elementary teachers have had calculus. This is, if you haven't had calculus, I'm going to teach you really, really fast how to take a derivative. Are you ready? X squared, the derivative of x squared, you take the 2, you multiply it by the 1, you put a 2, and you lower the power by 1. So if this is the function, the derivative of that function is 2x to the first. If I have 3x to the 4th is my function, my derivative is we take the power times the coefficient, get 12, and then we lower the power by 1, you get, right? Okay, are you with me? Let's take the derivative of this. What do? Take the power times the, and we get 4 pi r, lower at 1, squared. This, the surface area, is just the derivative of the volume.